So let's talk about setting this whole thing up to create the aorta. Let's use the tools we have and what we know. See if we can make this. I'm going to take off this I don't remember how to do it. Object display, heads up display. I'm going to turn off that poly count so that doesn't distract us anymore. I've got my 4 windows open, and you can see I've already created a curve here. So that curve matches my, from the side view, matches my vertebral column. Now, this is a my 12 thoracic vertebra. I've worked with modeling at different points in time to get a lumbar collection. I'm not sure it's 100% accurate, but it's pretty close. You do not have to add lumbar, but you could take your thoracic T12 and dupe it 5 times. Just give yourself a rough estimate so you can create this curve. Let's for right now hide that curve. We'll talk about how I created it in the lesson here. So I've changed my grid, trying to make it a little simpler. I went into the grid and I have a length and width of 20 and a grid line every 1 unit. I made the subdivision one as well. Just what that did is it just simplifies it so it's not as complex as it was. And what I'm using that for, I'm going to go to this front window now, is to help me keep track of how big things are. So I looked up on in Gray's Anatomy the length of the 12 thoracic vertebrae, and it told me they are, I believe, 21 centimeters long. So here's the page, just to remind myself. Talks about the curves and surfaces of the vertebral column, and I know in the Gray's Anatomy it gave me the actual length. Here's the page I was looking for. I did a Google search to get to Gray's Anatomy, and then in the Gray's Anatomy search I said thoracic vertebra, and it gave me a choice. The vertebral column as a whole, and these are the stats I'm showing you. Whole thing is 71, cervical is 12.5, thoracic is 28 centimeters. So what I was trying to do is use this grid to give me 28 centimeters. And I really did initially. I had these numbers that you see here, and I got it up to 28. The problem was I wanted it to, I scaled it back a little bit after I got the proportions down, just so I could have have my objects fit on the screen a little easier for me to work with. So when I got my vertebral column at that level, I then looked through those anatomy sections, what's called the Virtual Human Project, the VHP sections, and I have those on your My Courses here. I think I have it right here. Here in the instructions you can see them. So these are the instructions that I had to do this. So I used section 1380, and then I went down to section 1480, and that helped me construct this. Now 1480 and 1380, they're 1 millimeter apart. Each, in other words, 1381 would be 1 millimeter inferior or caudal. So these are 10 millimeters or 1 centimeter. So it's really not that big a distance. So I worked with that, and I knew from looking at the anatomy, shoot, I'm going to close that page, that 1380 was at the T4, which is where the carina where the you can see here, that's the carina, the bifurcation of the trachea into the two primary bronchi. I know that's a T4, so that's T4, and then I'm 10 millimeters below, or 1480s, I'm sorry, 100 millimeters below, 10 centimeters to get down to my, my next level. So that's 10 centimeters down. So again, when I made my scale here and everything was all the way accurate, I just counted from T4 10 centimeters down and put my my two plates, my two image planes there. So if we go to our panels now, you can see what in the perspective window is kind of easy to see. So I lined up the vertebra and the spinal cord and positioned the first one, and there's, see I'm off a little bit the way I've moved this a little bit, but there's the carina. I can tell that's the carina because those light marks there indicate the cartilage of the trachea. There's the aorta, there's the esophagus, and here's where the aorta is coming out of the left ventricle. So we're below the aortic arch, but we nevertheless have the thoracic aorta. And then down here, at this point, we're still, now we're below, deeper into the right ventricle, seeing a little bit of that left, and you can still see the aorta back there up against the spinal column. Okay, so I put my spinal vertebra there in the same position as the vertebra on the photo. So the next thing I did is I made rings. You don't have to really do that. Oh, shucks, this thing not going to hide. There we go. I made a ring. You can see them here now. So these rings, that's one ring I see, it's down a little bit, that's why I couldn't see it. Let me move it up just so you can see it a little easier. These rings were just originally positioned right on top of, they're just circles. I created neuroprimitive circle and put them in position to the photograph, and then I put one down here as well. Maybe we can find that one. I might have hidden that one. No. Oh yes, I did. I'm sorry. Yeah, there it is. Now these rings, there's 3 of them, but in reality only one of them is really a function. The other 2, this is the curve, so let me hide that for a second. So these 3 rings represented those positions on the photograph of the transverse sections. And they're really just a guide, so I wanted to make an arc that would then go through there, kind of hug the left side of the vertebral column, and then go through the ring down at the bottom. And that's what I made with this curve. Now, initially I forgot to go all the way down to the lumbar, and so I stopped there, but you can see in that a movie I have where I extended by just grabbing the vertice down and pulling that along. So if you get your surface and you don't like it, you can just delete the surface, edit the curve, or edit the ring, circle, and re-extrude it. So in this case, I grabbed the circle. I said edit, delete by type history, modify, freeze transformation. Did the same thing with the curve. Okay, then I grabbed the circle first, then the curve, and then went into the extrude. Now, if you remember, we did this initially for the ribs. Sorry, I said extrude. I meant to say extrude under the surface menu here. And these are the settings. I have this in your under my courses. So those are the settings I used. 480 again is arbitrary, but it just gave me a nice set of faces so that I could pull things to make the other vessels. What else I want to tell you about? Oh, in here I scaled this 0.58%. The reason I scaled it like that is this. When you look at the your My Courses, it gave me the dimension, the diameter of the aorta in the ventricle. And then it gave me the dimension, the diameter of the aorta distally, at its, before it bifurcated into the two common iliacs. That distance, that differential, ended up being 0.58%. So what I'm telling this to do is start at this size, and by the time you get all the way down to the end, reduce the size to about 58%. Now I've modified things. I pulled this surface. So let's take this surface, for example, right now. And, the one I made before, you notice this little interesting point here. See how the edges are more packed. There's more denser, I should say, here than they are, for example, up here. Now, why is that? Well, I think what you'll see, if I can find that curve, let's go under the outliner here so I can get to the curve. Trying to see if I can get just the control vertices. Alright, so the polygon's in my way, so I'm just going to hide the polygon for a second. So my point being, look down here, see that there's a smaller distance here between these control vertices versus here. So that's why you're getting a denser collection of polygons edges, because that distance is shorter than this. So it's spacing them out. So when you make the curve, you may want to put more in, or like we talked about in one of the other lessons, I can say vertex, grab that, maybe make pretty large soft select and say average vertices. And it still doesn't get rid of the range, still keeps them about the same. So you can play with that a little bit. Either make your points on the curve a little more evenly spaced. I think there's actually a way we can do that too. I think if we click this, it's a curve. See, I think if we rebuild this curve, you can add points, and didn't look like it did anything, but I think you'll see. See how now I've got vertices that are uniform. So instead of just a few I had when I said rebuild it with 12, it put all these points on this curve now, and space them mathematically the way it thought it had to make the curve. So let's see if we rebuild this. So again, surface is extrude, and say apply. See how now that's all even? Okay. So if I if I compare it to the one we originally made, see, there's the one where it's a little more packed towards the bottom. Here it's nice and even. So that's, you know, a way of getting yourself a nice UV map. Let's see what the UV looks like with this. See, we've got a nice, like we had before, a nice spread out UV, pretty evenly spaced, so that textures or colors or whatever we put on there should really be pretty effective. Okay, so that's essentially how I built this to begin with, and then you've got a printed lesson, and there's a number of lessons where I showed you how to do a lot of the vessels.